All right, hi everyone. Welcome to my home office, also known as my floor. Um, I'm just going to walk you through the problems that you had put on the discussion board so that you can do the quiz and we'll all be kind of up to date. So the quiz will be on Google Forms. You can't really show your work, so just put your answer down, and then I will go over the quiz, or I'll just post a solution so you can see it. All the problems that I'm going to go over right now, I took a picture of my work and I will post that as well. So if you have trouble like seeing it, or you want to like see it all together, it'll be all together. Okay, so I'm going to do, a lot of people had problems with the bond enthalpies. So essentially, when you make a bond, you're going to get energy back. When you break a bond, that costs energy. So we need to figure out whether we are going to put enough energy in to break the bonds, but also like get that energy back. So how much bang for our buck are we getting by making our products? Okay. So number 5 from the homework, I have my whiteboard here. So here's that. Here's your equation. Okay. There it is. Okay, so I need to draw these Lewis structures out. I'm going to give you the Lewis structures. So if you can't or you don't remember how to draw a Lewis structure, I gotcha. You should know from Chem 1, but since I'm not covering that, I'm not going to expect you to do it. All right. So this looks like this. Okay. There it is. We have Br2 plus C2H2, which is ethyne, which is a triple bond. And then we break up that triple bond and we put our bromine onto our CC. So essentially, you just need to highlight what's broken and what's formed. So I have 2 Br2s, so I'm going to draw this twice. Okay. And that way, I won't leave it out. So I got to break 2 Br bonds. I'm going to put my little squiggles. I also need to break this C triple bond because although carbon and carbon are still connected, we have to break a triple bond to make a single bond because they're different. They're shaped differently. They're oriented differently, so we got to break it. So now I'm going to circle all the stuff that we form. So we form our CBRs and we form our CC single bond. So there's that. Okay. So when I add these together, what I do is I'm going to look for BR-BR and what the bond dissociation enthalpy is for that. A CC triple bond. Those are the stuff that I'm breaking. So that's what I need to add. That's how much energy needs to go in. We need to put into this. So 193 is a BR-BR, and they gave you this information, and I will give you this information. And 837 is my C triple bond. Notice how much more energy a triple bond is to break than a single bond. Okay, the other side we get energy back. That's exothermic, so we need a negative sign. So we have a CBr bond and a CC single bond. So our CC single bond is 347, and I'm going to make it negative. And my CBr bond is 276 times 4. Okay. There you go. So now we just add these up and then add them together. Bonds broken plus negative bonds formed, and that's going to give me my answer. Okay, so when I do all this out, that's what you get. All right. Again, I'll give you the Lewis structure, and then you can do the rest. Okay. So the next one people wanted to do was 6, so let's do number 6. All right, you guys, here's number 6. All right, we have XeF2 plus 2F2 gives us xenon F6, XeF6. Okay, so those are the Lewis structures we got. So the bonds that we're breaking in this case are just going to be my 2 fluorine bonds. And I drew two of them because there are two. So I'm going to just break those. And then I have to form 4 new XCF bonds. Okay. All right, so they gave us the numbers. So an FF bond is 159 kilojoules, and I'm going to multiply that by 2. And then an XEF bond they gave us is 147. I'm going to multiply that by 4 because we have 4 new ones. There were already 2 there, so we don't need to add 6. And then make it negative and just add those up and see what you get. Okay, you guys, so there it is. That's number 6. Let's do number 7. There is the problem. We have CH4 plus 2O2 gives us CO2 plus H2O, and forgot my plus. So we need to figure out what bonds we break and what bonds we form. So we basically break everything. There's no more CHs and there's no more OOs. So we're going to break all of this. Make sure you draw 2 oxygen or dioxygen so that you don't forget. And then we form everything new. 2 COs and 4 OHs. If you didn't draw those 2 water molecules, you wouldn't know there was 4 of those. All right, you guys, so just look them up, add them up. We got 4 CHs that we are breaking, 2 OO double bonds that we're breaking, and then we have 2 CO bonds that we're forming. That's 799 when it's in CO2. It's different when it's in other molecules. And then 4 OH bonds. So just add them up. Remember to make these ones negative because this is the exothermic process. This is the time we get energy out. And you should be set. Okay. Okay, so the next type of problem that people were asking about is the formation constants. So you will have the table in front of you, or like you'll have a way to find that information. You're never going to have to look that up. I'm sorry, you will have to look that up. You're never going to have to memorize it. What I like to do first is switch the equation around. So I did that for you. So for number 15A, it was C2H4, there we go, that's ethene, plus H2, and then you're making C2H6. Anyways, this is a single bond, that is a double bond, that is not ethine, that is just ethane. Good Lord. Okay, so what I did first is I switched my equation around because products minus reactants. And so since these are your products and these are your reactants. So since it's products minus reactants, I feel like it helps to switch it and then put the numbers underneath, because otherwise people tend to just put the numbers down and then do the math like that, and it's always backward. So throw this one here and then subtract the reactants. The reactants are C2H4 and H2. H2 is elemental, so it's 0. You look up the other values. So this one is 84.68 in negative. And then this one's 52.4. You just subtract them and you get your answer. All right, so there's the answer over here, 137.1-ish kilojoules. So I skipped B because it's the same as A. Part C, now we have coefficients. So notice in front of NO2 there's a 3, and in front of HNO3 there's a 2. So we just need to make sure that we incorporate that. So what I'm going to do is I'm going to switch it, and I'm going to say, okay, well, NO plus 2 HNO3 in parentheses, and then we have to subtract 3 NO2 plus H2O. So now I can look that stuff up and just throw it in there and it should come out. Okay, fingers crossed, because I feel like my brain is mush. All right, okay, so there's our values. So now we just add them up. All right, you guys, there it is. There's the math for you. Switch the equation around, look up the values under the delta H column of your table, and then just plug them in. And it's always products minus reactants, so you could go backwards. I think that was everything, you guys. If there's anything else that you need, the quiz is going to be on Google Forms. There's also a lab-based question it's from the material last week. It's on a calorimetry problem. So it's all open book, open note. So just get that in, and that will count as our quiz. So I hope this was helpful, and I hope I answered all your questions. Please keep the discussion going if you want. I'll start a new one for next week for test material and for week 3 information. And have a fun snow night.